Okay, so in this video we're asked to identify which of the following integrals are improper. So some of them are going to be improper, some of them are not going to be improper. We just need to identify which one is improper and why. Okay, so first one immediately I look at is 0 to pi by 4 of tangent x dx. So tangent pi over 4 is just 0, is 1. Tangent of 0 is 0. So clearly tangent of x is defined within these two, within this interval. Is there any point in where within this interval if we're going to have tangent of x to be undefined? Well, no, tangent of x is defined between 0 and pi over 4. So this is actually not an improper integral. So not improper. And we can specify by saying that the function tangent of x, I should just say tangent of x is defined everywhere, defined within or between the bounds of integration. So defined everywhere between, I should say, 0 and pi over 4. And then included. So I should say between 0 and pi over 4 inclusive or something like that. Inclusive. And maybe I can go over to a graph or something to show this, right? So let me go to Desmos here and let me type in tangent of x. That was cotangent, by the way. So this is tangent of x. So here we have pi, we have 2 pi, we have 0. Pi over 4 is going to be someplace in between, right? Someplace in between here. So since this is pi over 4 is going to be 1/4 of the way in. And it's going to just yield a result of 1. So it's going to be somewhere over here somewhere, right? Because 1 is here, so it's going to be somewhere over here, close to here. And so it's just going to be the area under the curve from there to there, which is defined, right? It's not an improper integral, okay? Let's go back. Okay, that's that. So not improper, tangent x is defined everywhere between 0 and pi inclusive. That's okay. Let's look at part B. We have from 0 to pi, so it's the same tangent, it's the same functions, tangent of x, but it's from 0 to pi. Let's jump over to Desmos once again because we have it opened. And 0 to pi, we actually have it from 0 to pi. And notice that we want to find the area between this, but we do have a value where it's undefined in between here. So this is going to have a vertical asymptote in between. So this is going to be improper. Vertical asymptote in between. Okay? In between the bounds of integration. The bounds, I should say, in between 0 and pi. That's part B. Part C is from -1 to 1 dx over x squared minus x minus 2. This is a clear one. We have to identify if it's improper or proper because we have a denominator that's going to be set equal to 0, and if we have a vertical asymptote in between here, then it's improper. So let's factor this. So two numbers that multiply to -2, we can try 2, 1, and -2 we should try -2 and +1 because that also, when we add these two, we get -1. So this is just x minus 2 and x plus 1 equal to 0. So x minus 2 equal to 0, which is x equal to 2, x plus 1 equal to 0, x equal to -1. We have two asymptotes, but we have to ignore the 2. We don't need to worry about that. It's not between this or any of these. But x equals -1 is this one right here. So it is improper because we have a vertical asymptote at that point. So improper vertical asymptote at x equals to -1. That's it. Last part, let's do part D. Part D is from 0 to infinity e to the -x cubed dx. This is actually going to be improper because we have a infinite bound of integration. So improper infinite bound of integration. And let me actually go over to Desmos to show you this function. So this is e to the negative x cubed. So if we go over to Desmos, e to the negative x cubed. So this is going to be something like this. So we're going from, what were the bounds of integration? Let me hop over. The bound of integration was from 0 to infinity. So it's going from over here all the way to infinity. So if we zoom out, it's going to go all the way there. So it's an improper integral. We're looking at an infinite bound of integration. Okay, so whenever we have an infinite bound of integration, or we have some vertical asymptote, we are going to be classifying the integral as being improper. So that's one quick way to identify, is if we have infinite bounds of integration as like this one, we will have improper integrals, or if we have vertical asymptote in between, or in between the bounds of integration, or if it is one of the bounds of integration like it was in part C. Okay, I hope you found this video helpful.